Hey chemistry students, this is the final lesson in Unit 8 where we take a look at reaction types. So the first goal for the lesson is to get you to recognize the different types of chemical reactions. And then the second goal is to give you some practice predicting products of reactions if you know the reactants and the reaction type to figure out what you would get as products out of a reaction. So let's get started. So what we'd like you to do in your note sheet is create the chart that you see here. It's a 3-column chart where we're going to list the types of reactions down the left-hand side, and then leave a pretty broad space for your description and a generic equation for the reaction type. And then we'll give you a specific example of the reaction in the third column. And what we're going to do is deal with each one of these: synthesis, decomposition, single replacement, double replacement, and combustion as a separate slide. And then as we put that slide up, you can copy the information onto your chart. So if what we would recommend you do right now is pause the video and copy that chart into your note sheet.
All right, let's go start with these then. All right, so the first one we're going to look at is the synthesis reaction. The description is when two or more reactants combine to form one product. So if you had oxygen plus iron to form iron 2 oxide, that would be an example. Sorry, I already kind of skipped ahead there, sorry. So the generic equation would be A plus B yields AB.
And obviously that's going to need subscripts or balance,
yeah,
possibly, but you have two or more reactants, and then you end up with a single product forming. They join up.
And the example I started to give prematurely was if you had oxygen combining with iron.
And of course, we need to write
diatomic.
2
plus iron combines to form, let's say, iron 3 oxide, just to get some
iron 3 oxide, so that would be
Fe2
Fe2O3.
And there you have a good example of a synthesis.
So the second reaction type we're going to cover is called decomposition, which is really the exact opposite of a synthesis. In this reaction, we're going to have a single reactant substance, and then the reaction breaks it down into 2 or more product substances.
So the generic equation for this one would be AB yields A plus B.
And obviously that would need to be balanced.
Yeah, so a good example for this would be hydrogen peroxide. This is why that comes in dark brown bottles, because it decomposes in light. So H2O2 decomposes into water and oxygen. And of course then you'd have to balance this.
Well, let's balance it.
Okay, so we need half, so it's 2, so we need half as many oxygens as what we already have. So it's going to be 2, 2, 1, I believe, for a balanced equation.
2, 2, 1.
Yep, because it's 4 hydrogens on the left, 4 hydrogens on the right, 4 oxygens on the left. 2 plus 2 is 4, so we're good to go. All right, on to the next one. So the next type of reaction is a single replacement. We have done these in the lab several times this year.
We've done a demonstration
and demonstrations as well. So the description is an element replaces another element in a compound. So your general for this one would be A plus BC yields AC plus B.
It's just a swap.
Yep. I mean, there's rules for how this occurs, but we're generally just going to show you examples and you write them down. So an example of this would be iron plus copper sulfate, copper 2 sulfate. The activity series is what I'm referring to, for how we know when they swap out.
When they're going to swap, okay.
Yields copper plus iron 2 sulfate.
And I believe that equation's balanced as it's written, isn't it?
Yes, and if we want to, we can put a note here saying C activity series. I don't believe we actually talk about that, but it's good for them to know.
Because you can't just put any random element with a compound. It's certain if you have a more active element as the loner, and a less active one in the compound, then the
Copper
reaction will
is
go.
more stable as an element than iron is, I guess is a way to put it.
Okay.
So, see activity series.
But that's a little more advanced topic.
We'll
that
talk about
maybe
that in
we'll
AP
get into
chemistry or
AP
advanced
if you take
chem.
that.
All right, next one.
So building on the single replacement, the next one's called a double replacement, and this is going to involve two compounds, and they're going to react and they exchange atoms or ions. Most often these are ionic compounds. So what would the generic equation be, Mr.
So
Hunter?
let's go with A plus B.
How
Or
about
AB,
AB
sorry. Or AB plus
plus
BC, or CD.
CD.
Wow, I'm bad at
Okay.
this. CD yields AC. No,
A-
AD. Let's try that again.
AD
Plus.
plus CB. And why did I reverse the order? Because the C
Positive
would be
ones
the
go
positive cation, and the cation always comes first in the formula.
Yeah. So then, an example of this would be iron sulfide.
So that's going to be iron 2 sulfide.
Iron 2 sulfide.
So that would
yeah,
be
sorry.
FeS, because S is a -2 ion.
Plus HCl, hydrochloric acid.
Okay. So you can think of it as the cations are going to swap places with the anions.
Yields FeO2. So iron 1 oxide. Oh, that's different. It's FeCl2.
There's a mistake.
There's a mistake on our example here. Sorry.
FeCl2. So that's
Plus-
iron 2 chloride
Plus H2S.
plus hydrogen sulfide. And we need a little balancing work here.
We
I'm
need
thinking we
two
need to put a
HCls.
2 there,
And I think we're good.
and that's it.
All right, last example, or we are the last one, aren't we? All right, so the last one here is a combustion reaction. I was mistaken. There is, I think, this last one. It's when a fuel, which is often a hydrocarbon or alcohol, reacts with oxygen to form water and carbon dioxide. In most combustions, if not all, oxygen is always present as a reactant. So the only thing we can say about the generic equation is that you'll see O2 in it.
You're going to have something plus O2, and your products are going to be
Normally.
some number of
Waters.
plus some number of CO2s.
Yeah. All right, so
they're
then
pretty predictable in that way. Balancing them is
sometimes difficult.
sometimes tricky, and especially with the bigger hydrocarbons.
So let's take an easy example. Let's take methane, CH4, plus O2. And of course, this is going to yield CO2 plus H2O.
So we need a little balancing here, I think.
Yep, I
And the
believe
rule
this
is, for this is a simple one, we would always do the carbon, then the hydrogen,
And
and
always
then
the
the last
oxygen
number you
last.
want to fill in is that one on that oxygen.
Yeah, so right now we need 2 H2Os because we have 4 hydrogens, which is going to cause us to need 2 oxygens, or 2 O2s, and that will actually balance this equation for
Right,
us.
so we don't need anything on
And
the
there
carbon
was
dioxide
there.
or the methane, so that's balanced. So that's combustion, and now let's go to some examples and see if we can identify them.
All right, so on page 29, that's what we're looking at in our packet. Of course, next year it may not be page 29.
This year it's page 29,
But
so this is the
this
first
page
4.
that we're looking at, we're not going to worry so much about balancing, I don't think, right now, because that's an older topic, unless you really want to.
I think the main thing is, can you look at the reaction and see what's going on and identify what
So-
type of reaction we're dealing with?
So right now we have sodium bromide plus phosphoric acid yields sodium phosphate plus hydrobromic acid. So we are swapping the cations with each other, and that means we are doing something known as the double replacement. So we just put double usually. If you want to spell out replacement, go ahead.
Double rep.
Okay. And the next one, we have calcium hydroxide plus aluminum sulfate is yielding calcium sulfate and aluminum hydroxide. Once
That
again,
looks like the same.
looks
same
like a double
thing.
replacement.
Again, these two ions just swapped out with each
Yep,
other.
so that's a double.
So we've got here, I'll make you happy. D period R period.
There we go. For number 3, we have the element magnesium reacting with iron 3 oxide to yield iron plus magnesium oxide.
So now we have one element, and it's swapping out for another element in the compound. That would be our single replacement.
All right, and then lastly, we have what looks to be ethene plus oxygen yields CO2 and H2O. So that to me looks like a combustion reaction.
Me too.
And then you'll have more practice with this when you finish page 29.
In fact, what we'd like you to do is after you watch this video, finish that just for some practice. You can balance them if you want, although a lot of you have, if you feel like you've mastered the balancing, I think, that I don't need you to do that. You can do it for extra practice if you want, but what we would like you to do is focus on identifying the types of reactions that you're looking at.
But make sure to finish page 29 for class tomorrow. That way we can kind of hit the ground running. All right, have a good night.
I need to add to this that this year it's not page 29 at all. You're looking at page 21 in this year's packet, so everything else we said is correct, but see if you can finish page 21 as your post-video question. See you soon. And I almost forgot, we didn't really practice any of the second kind of problem that we talked about initially, and that's predicting the products of a reaction. So I put a few examples on here. We'll do 2 of them together, and I'll give you one more as an additional post-video question. So this type of problem, we tell you iron reacts with oxygen, and the type of reaction is a synthesis. So what would the product be? Iron plus oxygen. In the synthesis reaction, you're going to get those 2 reactants going together. I would predict iron oxide. Now there's different iron oxides, iron 2 oxide, iron 3 oxide. Let's say it's iron 2 oxide. So that would be FeO. So again, 2 separate reactants going together to make one product. That's synthesis. Okay, now the second example, we have hydrogen chloride, hydrochloric acid, reacting with sodium hydroxide, and we tell you that it is a double replacement reaction. So again, remember the cations are swapping. So let's try this one. We have HCl. That definitely would be aqueous. Plus NaOH, also aqueous. So now we're going to expect 2 products, and remember, we're going to be swapping the sodium and the hydrogen. So I'm going to predict sodium chloride as one product, aqueous, and the second product is going to be the hydrogen with the hydroxide ion, and this is one that sometimes fakes people out, because if you write it as HOH, sometimes not clear what it is. That's really H2O, that's water. Okay, so this is a special case of a double replacement reaction. This particular one, we have a base reacting with an acid, is called a neutralization. You're always going to get some sort of ionic salt or ionic compound, and then water as the other product. Alright, here's the one I'm going to let you with. So we know ethane is a hydrocarbon. Hopefully you can figure out what the formula of ethane is, and I'm only giving you one other clue: combusts. Combusts. So we looked at combustion as one of our reaction types. See if you can sort out what the products are that you would predict from that reaction. Okay, see you soon.